Here is question number 9 with us. How many non-congruent triangles that have a perimeter of 20 units are possible if the lengths of the sides are integers? So I would try to tell you the method through which you can calculate these triangles, that how many such triangles are there. First thing, if the perimeter is equal to 20 units, that means the largest side has to be less than half of it. It is because of one simple rule of triangles that sum of any two sides should be greater than the third side. So if sum of all the sides is 20, the largest should be less than 10. That means the largest can be maximum 9. So now start making cases. Let us say one of the sides is 9, which is the largest one. So can I say sum of the other two sides must be equal to 20 minus 9, which is 11? And how can that be formed? It can be formed by 9 and 2, it can be formed by 8 and 3, it can be formed by 7 and 4, it can also be formed by 6 by 5. There is no point taking 5 and 6, 4 and 7 because they would be repeated. And I would not take 10 and 1 because the largest side is 9. So you can't take any side as more than 9. Then make the second case. What if the largest side is 8? What if the largest side is 8? If the largest side is 8, sum of the other two sides is equal to 12. If sum of the other two sides is equal to 12, in that case, sum of those two sides, which is 12, is 8 and 4, 7 and 5, or 6 and 6. Right? These are the only three possibilities which can be found. Third, what if the largest side is 7? Then sum of the other two sides would be 13, and 13 would be formed with only one case, 7 and 6. I can't take 8 and 5 because I'm assuming largest is 7. And I'm not saying 7, 8, 5 is not possible, but it has already been counted here. Look at this, 8, 7, 5. So by this case, you basically make sure that no case is repeated or double counted. So ultimately, I have these all cases and I cannot have the largest side as 6 because if the largest side is 6, then sum of the three sides is maximum 18. 6 plus 6 plus 6. But we need a perimeter of 20. That means the largest side has to be minimum 7. So therefore, by checking all the cases, I see 4 cases are here, 3 are here, 1 is here. The total number of triangles that can be formed is equal to 8. So 8 is the correct answer for this question. This question would seem very easy for a person who has studied this concept before. Otherwise, you might find it a little difficult.